class, back again with another video. This time it's about completing the square in terms of quadratic equations. So just as a precursor to that, if we can review perfect square trinomials, so a plus b squared or a minus b squared is equal to this in standard form. So the first and last terms are perfect squares. And the middle term is 2 times the square root of the first term times the square root of the second term. So for example, for this one, you can see in terms of the coefficients, this has a coefficient of 1, and this value here is 144. Well, if we know that the square root of 1 is 1, the square root of 144 is 12, what we're saying here is the middle term would be 2 times 1 times 12, which is 24. And if that's the case, then we know this will be a perfect square trinomial, meaning this would be equal to x plus 12 times x plus 12. And then that can be simplified as x plus 12 squared. And if this was expanded with FOIL, you'd get this original equation back. So if we look here at this equation, the coefficient here is 1, this is 91. So using again the same formula, the square root of 1 is 1, square root of 81 is 9. And if we take here 2 times each of those square roots, so 2 times 1 times 9 is 18. And that equals our b there. So therefore, since that's satisfied, we can say this is also a perfect square trinomial, but since this is a negative sign here, it's going to be x minus 9 times x minus 9, which is the same as x minus 9 squared. Now here, can you make these perfect square trinomials? So if we look here, and we know that this should be 2 times, and this we know is a 1, the square root of 1, and the square root of something else. Will that equal 10? Well, we know that the square root of 25 is 5, so 2 times 1 times 5 is 10. So that's how here we would get 25. So this would be equal to x plus 5 times x plus 5, which is simply x plus 5 squared. And then the same idea here. So what you can also do is you can pause the video and see if you can come up with this value. So pause the video. All right, welcome back. I hope you paused it. And you see here again is a 1. Now, for this term, what would we multiply? In this case, negative 2 times 1, square root of 1, and the square root of something to give us 24. Well, what can we multiply 2 by to get 24? Well, we know that would be 12. And 12 squared would be 144. So therefore the square root of 144. So we've got here 144. So then this would be x minus 12 squared. I just skipped to the middle part there. Hope that's okay. So the last term of a perfect square trinomial is the middle term squared. So half the middle term squared. So 10 over 2 is 5, squared is 25. 24 over 2 is 12, times squared is 144. So now what we're going to do is we're going to use that knowledge to help us complete the square in terms of as a way of going from standard form to vertex form. And in my video, in the lesson for the class, I'm not going to do partial factoring. I'm only doing completing the square. So the steps we're going to follow in completing the square is you're going to put the brackets around the first two terms, and then you factor out the number that's in front of the x squared, if there is one. And then you look at the last term in the brackets and divide it by 2 and then square it. So maybe what I'll do is I'll go through an example by reading the steps, because it's hard just to read them. It's boring. So let's say we go here. And following those steps, the first step is put the first two terms, put brackets around the first two terms. So I would simply have x squared plus 8x plus 5. And that's it. So it hasn't changed the equation at all. And then the next is factor out the number in front of the x. Well, there is no number there. It's 1. So we don't need to do step 2 at this point. And then it's saying the second term. So if we look at the second term, what we're going to do is we're going to take it, divide it by 2, and then square it. So we're creating a perfect square trinomial is what we're doing. So we know that 8 over 2 is 4. So then you would have 4 squared, which is equal to 16. So I just took this, that's how I got the 4, and then I squared it. Now what I do with that is I keep everything the same. And I'm going to take this 16, which is essentially 4 squared. So even if I leave it as 4 squared plus 4 squared minus 4 squared, so you add it, you subtract it, it's like they balance out. So you're not changing the value of the equation at all. And then so that's step 4. Now step 5 is move the negative term outside the bracket. And we'll see in the next example, if there's a number in front of the a, we have to carry that one. We have to make sure we multiply it by that a value. So what we're doing here is then we have x squared plus 8x plus 4 squared. And now this moved out, so we have minus 4 squared plus 5. And we know 4 squared is 16. So now we have x squared plus 8x plus 4 squared. Since that's 16, minus 16 plus 5 is minus 11. Now if we look at this expression, this is a perfect square trinomial because this b term is 2 times the square root of this. So then we can rewrite this in vertex form as x plus 4 squared minus 11. Okay, we'll do a few examples, and then you should do the homework where you practice this as well. So given the vertex form, we know now that the vertex of this equation will be negative 4, negative 11. So remember, the general form of a vertex equation is y equals x minus h squared plus k. So this is similar to the transformation. So if this is positive, it means that that coordinate is negative. And then is the vertex a max or a min? Well, for that, remember you look at the a value, and the a value, since you don't see anything here, that means the a value is 1. And we know that 1 is greater than 0, so therefore there's a min point. The parabola will look something like this, and that this point right here is negative 4, negative 11, the vertex. All right, I'm going to pause and go to the next page. All right, so then after this example, I'll probably start another video afterwards. Yes, chop it up. So here, following the same steps, put brackets around the first two terms. And then the step we didn't have to do before, which is step 2, is we factor out the number that's in front of the x squared term, which is 2. But that means we have to factor it out of both terms inside the brackets. And that's going to be our a value. So here we're left with x squared, and here we would be left with negative 6x, and then plus 11. And then the next step is we look at that second term, and remember we want the b over 2 squared, which would be, well, it looks like a 6 anyways, 6 over 2 all squared, which would be 3 squared, which is 9. So given that, then we have y equals 2 x squared minus 6x. Now, maybe if I leave it like the 9, I don't know which one makes more sense to you, the first example or this example, plus 11. So all I'm doing is I'm taking this and I'm adding it, then subtracting it. We're forcing, again, we're trying to make a perfect square trinomial, which we'll get from the first 3 terms. So the next step is we have to factor this term out, but we have to multiply it by that a value. So I'll show that. So we have 2 times x squared minus 6x plus 9. And now if we move this one out, we have to also take that 2 with it. Negative 2 times 9 plus 11. Now, here we have a perfect square trinomial. That will be equal to x minus 3 all squared. And if you're not sure, try to expand that to convince yourself. So here, this is 18, so then we have minus 18 plus 11. So then our final answer here would be minus 7. All right. So if you have questions about this, make sure you ask me and I can help out. So I'm just going to move the page up a little bit. So now that we have the equation in vertex form, we can say, oh, just a moment. Sorry, just a bit of an interruption. So here with the vertex form, again, remember the general form of a vertex equation is y equals a x minus h squared plus k. So you have to remember that form. So the vertex is the h and k. So in this case, it's 3 and negative 7. And is the vertex a max or a min point? So you look at the a, and now our a is equal to positive 2. So that means there's a min point, because if it's positive, then it's an upward facing parabola, and 2 is a stretch factor of 2, if you remember that from transformations. So this point here would be 3 minus 7, and it's a min point. Excellent. Okay, so I'm going to make a new video after this one.